Good morning, everyone. Today we're going to learn how to calculate the slope between 2 points without graphing. So take a minute. You might have to pause it when you need to if I'm going too fast or you need to write things down, but you should take a minute, write down your title, add the date, and while you're doing that, I'm just going to write down the slope formulas that we had the other day. So we had slope is equal to, we always used m for slope. Slope is equal to y2 minus y1 over x2 minus x1. And those are, the 1s and 2s are subscript, like H2O. They're not exponents. The other one you had was m equals rise over run. And then the third one that we had was delta y over delta x. So normally you would use this when you have coordinates, this off of graph, and this with a table of values. But you can use any of them anywhere really because it's all kind of the same thing. So for the first one, it says calculate the slope through each pair of points. So what I'm going to do is I'm going to call this x1 and y1. And the second one is going to be x2 and y2. So what I'd like you to do is pause it for a second, try and calculate the slope. So replace the x1, y1, the x2, y2 into this formula, calculate the slope, reduce it where you need to be reducing it, and press play to continue and see if you're getting it right or not. So if I continue now, I'm going to have -1 minus 9 over -3 minus -5. This works out to -10 over 2, which reduces to -5. And it would be -5 over 1, but still -5. Take a minute, do the same thing with the next one, with part B. And when you're ready, unpause it, and you can see what the solution is. Slide up here a little bit. So when you press play again, you're going to have 396 minus 248 over 30 minus 10. Didn't bring a calculator with me, so I'm going to have to do this mental math-wise. So I think that's 148 over 20. I think that's right. And then reduce it. So they both divide by 2. So the bottom would be 10. 148 would be 74. Oh, they reduce more. They both divide by 2 again. So it would be 5 on the bottom, 37 on top. So the slope would be 37 over 5. So we want to leave it as a fraction in those terms because this tells us the rise over the run. So when we go to a graph, we'll be rising 37 and running 5. In this one over here, the first one, it could be 5 over 1, and that would tell me that the rise is -5 and the run is 1. We'll get more to that when we go to graphing. So again, pause it if you need to pause it. But I'll move on to the second one. It says, what are 2 other coordinates that pass through the line with a slope of -1/3 and passing through the point 3, 7? So what I'm going to do is I'm going to take this slope and I'm going to rewrite it as, that negative up front doesn't really help. So I'm going to stick that negative on in the numerator on the top. So it's going to be -1 over 3. And that tells me that the rise is going to be -1. It also tells me that the run is going to be equal to 3. So what I'm going to do is I'm going to make a grid. So you're going to need to draw a grid. So pause it and draw a grid. I know it needs to go up to, well, 3 and 7, 3 for x, 7 for y. So that's x, that's y. So make yourself a grid, pause it, make yourself a grid. I'm going to make a quick grid here. Unfortunately, I don't have a ruler, so this one's not going to look beautiful, but that's okay. I'm just going to do a sketch. So 3, 7 is going to be about 2, 3, 7, 1, 2, 5, 6, 7. So it's going to be about there. So that's the point 3, 7. That's P. So when you're making points, it's best, especially with something like this, to label them. So that's P. The coordinates are 3, 7. Then what I'm going to do to find 2 other coordinates is I'm going to go from this guy. I'm going to go down 1 to the right 3. So down 1 to the right 3. I have to add 1, 2, 3. So that's where I end up. down 1, to the right 3. When you're running, your run is always to the right. Just think like you read a book, left to right, always to the right. So my new coordinate here is gonna figure out the new coordinate by using the rise and run. So I know that my the y coordinate was 7. And since I'm rising affects up and down. So since I went down 1 less than 7 would be 6. So my new coordinate would be 6. And that matches up on the graph. My grid's not great, but it matches up on the graph. If you have a nice grid, it should line up perfectly. For the run went to the right 3. So that's going to affect the x coordinate. So x, if I add 3 to x, I'm going to end up with 6. So I get a coordinate of 6, 6. So 6, 6 would be on this line. Okay, I need to find 2 other coordinates, so that's 1. Another coordinate, same idea, go down 1 over 3. 1, 2, 3. So it's going to be about there. And use the same process. So now I went down from this one, 6, 6. So my rise is -1, I go down 1. My y value is going to go down 1. So now it's going to be 5. The x value, same idea, it went over to the right 3, so I'm going to add 3 to it, and it should line up with 9. So that should line up with 9. And on the y-axis, it should line up with 5. So those are my 2 additional points. You could, if you want, you can keep going, down 1 over 3, down 1 over 3, down 1 over 3, and changing the x and y for it to figure out as many coordinates as you need. You can also go backwards. So instead of going down 1 to the right 3, I do the exact opposite. So I could go up 1 and to the left 3, and that would put me there. So that's another option. So if you did that, you would have a coordinate of 0 and 8. I'll let you look at that one and make sure it makes sense. But it's easier to work your way to the right. All right, so we can write down any questions that you have. I can try and explain this better when I'm back tomorrow, or you can ask. So the third one says determine whether the points t, -5 and 4, u, -1 and 5, and v, 12 and 8 are collinear or not. So this word collinear, that's probably a new word for you. Collinear just means they're all in a straight line. So in a straight line. I'll give you some examples here. So 1, 2, 3. These are collinear because they make a straight line. Be better if I had a ruler, but I don't. So collinear. If they're not collinear, they don't make a straight line. So like those 3 points are not collinear. So if you want to figure out if something is collinear or not, you want to figure out if they're making a straight line. If they're in a straight line, and I work out the slope between 2 of them, so I work out the slope for these 2, it has to be the same slope as if I worked the slope out for the next 2, these 2. Or I could use the outside 2. They all have to have the same slope because they're all on the same line. If they're not collinear, if I work out the slope between this point and this point, it will not be the same as the slope between that point and that point. So if I take 2 of these points, work out the slope, and then check the slope of a third point, if they're all the same, then they'll be collinear. So let's do it. So I'm going to work out the slope. I'm going to start with t and u first. So I'm going to write m for slope, and I'm going to put a little t and a little u, so a subscript. And that's going to help me stay organized. It tells me that I'm finding the slope between t and u, between these 2 points, t and u. So I'm going to go same formula, x1 or y2 minus y1 over x2 minus x1. So I'm going to have x1, y1, x2, y2. So I'm going to have 5 minus 4 over -1 minus -5. And then, so simplify it. 5 minus 4 is 1. -1 minus -5 is 4. And that's the slope. It does not reduce. So now what I'm going to do, I know the slope between these 2 points, if I graphed them, would be 1/4. I'm going to go to the next point. I'm going to choose to do TV but it really doesn't matter. You can do whatever you want. So m between 2 and v, t and v. So slope between t and v. So I'll have the same x1, y1, but my x2, y2 are now going to be off the point v. So x2, y2. I'm going to substitute into the formula. So I'm going to have 8 minus 4 over 12 minus negative 5. So 8 minus 4 is 4. 12 minus negative 5 is 17. I don't think that reduces. 17 is a prime number, so I'm pretty sure that doesn't reduce. So I know that these slopes are not the same. So then the points are not collinear. So I'd say therefore the points are not collinear because the slope of TU is not equal to, so that's that symbol, not equal to, the slope of TV. Okay, and you don't have to use mathematical symbols. You can use words. You can just put the slopes are not collinear, or the points are not collinear because the slopes, the slope between TU is not equal to the slope between TV. Okay, so today is all about finding slope. So you're going to be working on, drop my pen. You're going to be working on these questions here. Oops. Okay, and we'll start taking them up tomorrow. Also, we're going to take up, I'm going to take up the breakout activity we did on Friday. I know a lot of people didn't finish, so I'm going to try and explain parts of it. Takes out a little bit of the fun, but I don't think Miss Altaf wanted to use it, so I had to reset them all, and then we lost where people were. So I'll go through it with you and hopefully explain where you went wrong. It was kind of tricky, but it was kind of fun. So I will see you tomorrow. Have a good day, and you can post questions if you want in Google Classroom, and I'll do my best to answer them, or you can wait till tomorrow. Okay? Have a good day. Bye.